In this video, we're going to talk about practice quiz number 6 on exponential functions. Number 1 says to graph the exponential function below and identify the key characteristics. They've given us y equals 3 to the power of x plus 2 minus 4. So the first thing I would do is type it into Desmos. So y equals 3. Make sure in your exponent that you group the x plus 2 with parentheses, and then that'll keep it all together in the exponent. Then minus 4. So first I want to graph the function, because that's part of the question, is to graph it. So I need 2 good points, or at least a good point to help me sketch this out. So I see I have an x-intercept at negative 0.7. So I'm just going to go to negative approximately 0.7. And I have a y-intercept at 5. So 1, 2, 3, 4, 5. And then I can also tell that it has a downward shift of 4. So that looks like where the horizontal asymptote is. So I'm just going to type y equals negative 4 because it went down. So you can see like that does make sense with my graph. So I know I have an asymptote at y equals negative 4. So what I'm going to do is highlight that line so I don't cross over it when I sketch my graph. So 1, 2, 3, 4 down. I'm going to highlight that imaginary line that I don't want my graph to go past when I'm drawing my exponential function. And then I'm going to sketch it like that. So I've got it graphed. Now I just need to answer a few questions. So the asymptote I've already figured out with Desmos' help that it's at y equals negative 4. It's always related to the vertical shift of your graph. And if there's not a vertical shift, it's just at 0. And you would always say y equals the number because it's an imaginary line. The domain of this graph, I can tell this graph is going to go left forever because of this arrow over here. And then it's steep, but it is technically going to go to the right slightly forever. So that means the domain is going to be from negative infinity to positive infinity. And then the range of the graph is how low to how high the y values go. So I can tell that the y values will go down, but not past the value of negative 4, because that's where my asymptote is located. So I can put negative 4, but with a parentheses, because it won't ever equal that value. And then I can tell my graph is going up forever. So that's going to be negative 4 to positive infinity for the range. All right. Number 2 says, given y equals 4 to the power of x minus 3 plus 8, state the parent function and describe the transformations. So the parent function is just y equals the base of 4 to the power of x. You take away the transformations to write the parent function. So I can see one transformation is that I have a minus 3 in my exponent, which is my grouping symbol in exponential functions. So minus 3 in the grouping symbol means it's going to shift right 3. Then I can also tell that I have a plus 8 outside the grouping symbol, so that's going to make my graph shift up 8. And you can use Desmos to check these transformations pretty easily. So like I'm going to type in y equals 4 to the power of x by itself. But then I want to check what the minus 3 is doing. So I'm going to group it in parentheses and put minus 3 and just watch what happens. So I can even type it in separate lines. So if I want to compare the two together, let me leave this original function there. So I can tell that from my parent function to the new function with the minus 3 included, I can tell the green one went to the right from the purple one, for example. And then if I want to compare what's happening when I add the 8, I would just put the plus 8 by itself and see what happens. So you're only looking at what happens with that added number. So from the purple one to the black one, it just went up 8. But you can like visually see that in Desmos if you need to. Okay, so on to number 3. It says, given the function p of t equals 100, 1 plus 0.05 to the power of t. So, and this represents a population of mice. Does the function represent exponential growth or decay? So it's 1 plus 0.05. So for that reason, I'm going to pick growth because that's larger than 1. What is the initial population of the mice? So that is the p-value of 100 that sits in front of the parentheses. What is the rate of growth or decay? That goes with the amount that we added to the 1, which is the 0.05, which is 5%. They will usually write that number as a percentage, so try to do the same thing while you're practicing these. And then how many mice will there be in 4 years? So we just have to use the function they've given us and plug in the time of 4 years and then calculate what that would be. So I'm just going to use Desmos for my calculator since I have it handy. So I'm going to type 100, 1 plus 0.05 to the power of 4. And I get 121.55. So then I would just round it up, since 55 would round that up to approximately 122 mice. Because that would be a good answer, since mice, we can't have like a part of a mouse. We just have mice. But let's look at number 4 on the next page. It says simplify the following expression. Show at least 2 steps. So what I want to do is show you 2 different ways you could do this. The first way I would do it is just distribute the power of 6 to each part of this quotient. So m would become 3 times 6. The little n right there has an understood 1 on it already, so I'm going to say that's going to become 1 times 6. The n at the bottom has a 2, so that'll be 2 times 6. And the little p at the bottom has a 1 understood to be there, and I'm going to do 1 times 6. So that shows where these numbers I'm going to get next come from. So I get m, and then 3 times 6 is 18. N, 1 times 6 is 6. N at the bottom would be 2 times 6 is 12 for my exponent, and then p would have 1 times 6, which is 6. So then I need to combine the 2 that have a like base, which are the 2 values of n. So leave m to the 18th. And we could think of this different ways. We could just subtract and say 6 minus 12 would give us a negative 6 in the numerator for now, and leave the p to the 6th power at the bottom. But then we just have to fix the negative and put it back at the bottom. So something else you could do from this step is think of where is the larger number, and just leave the n where the 12 is, since that's larger than 6, and then just subtract from the 12. Say, I know n's going to end up at the bottom because 12 is bigger than 6. And the difference between 12 and 6 would leave me with 6 more, and they would be in my numerator. Excuse me, my denominator. So that's one way to do it. The other way that you could do it is literally write it out 6 times, because that's what this power of 6 represents, is you're multiplying something by itself 6 times. So I'm going to plan ahead and put all my parentheses out here. So I would have m cubed n over n squared p 6 times. And I know it takes a minute, but sometimes it helps us to see what we need to do. So if it helps, it helps. And that's what matters. So I see in my numerator, I have 6 m's that have a power of 3. So they would all add up to give me the 18. Then I have 6 n's. And at the bottom, I have 6 n's with a power of 2. So that would add up to 12. And I have 6 p's. So then I get to this step doing a different way, but I would still need to combine the n's that have a like base. So I'd still need to figure out where to put the n and how many would be left. So if you're doing it with this method, you're probably a visual learner and you might actually want to write them out. So I could write out those 6 n's to see physically what they would look like. Let me scoot these over a little. So there's 6 n's at the top. There are 12 at the bottom. So I'm going to write them all out. And then the M and the P don't have anything else they need to go with. So I'm just leaving those alone for a minute. And then I can mark out these 6 N's would take away 6 of them at the bottom. And then physically I can see all that's left is at the bottom. So M to the 18th over N to the 6th, P to the 6th. And so there's a couple various ways you could show your work for this problem. But the final answer, no matter which way you work it out, should be this. M to the 18th over N to the 6th, P to the 6th. Okay, the last question says, after receiving her business degree from UNCG, Nyla is offered positions with 2 companies. Company A offers her $70,000 per year with a $1,000 increase every year. Company B offers her $60,000 per year with a 5% increase every year. Write a function to model Company A's offer. So Company A says $70,000 per year with a $1,000 increase every year. So that is just a linear function. We could say that is y equals 70,000, which is her starting rate of pay, plus $1,000 each year. So it just looks like 70,000 plus 1,000 times however many years she works there. Then Company B offers her 60,000 per year plus a 5% increase every year. So we could write y equals 60,000. But this one is exponential growth because it's a 5% increase. So we could say that's 1 plus 0.05 to the power of x, because it's going to go up 5% of her pay every year. Now we want to know, after how many years will the Company B salary be higher than Company A? So what I would do is just type them in Desmos and figure out where do they touch, because after that, Company B should be making more. So let's say 70,000, or Nyla will make more with Company B. So 70,000 plus 1,000x is one function, and then 60,000 times 1 plus 0.05 to the power of x is the other function. Those numbers are really large, so they might be way off my screen. So what I can do is change my window to show a larger y value of, let's just say 70,000 is like my y maximum. And then I get closer quicker to where they're going to touch. So I see that they touch over here in the positives, because I don't need this negative option over here. I only need positive because time is going to be a positive number. And I can see that they are equal to each other after 4.4 years. So after 4.4 years is when she would make more money with Company B. So after how many years? So let's say after 4.4 years, Nyla will earn more money with Company B. Would be a good answer. All right. So that is it for practice quiz number 6.